Hey guys, today we're going to be talking about absolute value equations, but these have an absolute value on both sides of the equal sign. It's a little scary. I'm not going to lie. It made me a little nervous. I was looking at what today's plan was. I saw some absolute values on both sides of that equal sign. I was like, oh goodness, what do we do, right? That's probably what you're thinking too. Fear not. It's not nearly as hard as you think. In fact, it's actually not that different from what we were doing with absolute value when we only had it on one side. Here's the deal. Our goal not necessarily goal, but our step of rewriting the equation twice doesn't change. That's actually still going to happen. I'm going to rewrite our equation 2 times without the absolute value bars. So when I say that, I quite literally mean 4x minus 3 equals 6x plus 7. And then I'm going to write it again. 4x minus 3 equals 6x plus 7. Now think back to when we were doing absolute value before. What did we change about that second equation? We made it negative, right? We made that answer negative. We're actually going to do the same thing here. The only difference is we have multiple terms. So we're actually going to change the sign of both of those terms. So that means we're going to make it a negative 6 and a negative 7. Now, if one of those signs was already negative, you would make it positive. You flip the signs. You change, reverse, whatever verb you want to think about here. You change every sign on the second side of that equation. Positive to negative, negative to positive. And we're going to solve both of these just like we would an equation with variables on both sides. So I'm going to go ahead and do that here. Recall that we always want to get our variables on one side and our whole numbers on the other. So I'll move my variables to the left-hand side. That's just kind of my easiest way of looking at things. Get rid of those 6 x's. 4x minus 6x is negative 2x. So negative 2x minus 3 equals 7. And then I want to move those whole numbers to the other side. Plus 3, plus 3. Those will cancel out, and we'll get negative 2x equals 10. We just have one final step left. Divide by that negative 2 and get x equals 10 over negative 2, or if you just divide those, x is negative 5. That's our first solution. We're going to do the same thing to this second equation. Get our variables on one side. So again, I'll go ahead and move my 6 over here. This time I'm adding it since it has a different sign than before, since it's negative in this equation. So 4 plus 6x gets me 10x minus 3 equals negative 7. I will add 3 to both sides. These are going to cancel out. And I'll be left with 10x equals negative 7 plus 3, or negative 4. And then I can finish this up just by dividing by 10 and getting that x equals negative 4 over 10, or if we simplify that, negative 2 over 5. Sorry, I was getting ready to write a decimal there. I don't know what I was thinking. And these are our 2 solutions. If we wanted to check those solutions, we could put them back into the equation just to make sure we did everything right. For example, if we wanted to say negative 5, I'll replace my x's with that negative 5. We have 4 times negative 5, or negative 20. Negative 20 minus 3 gets me the absolute value of negative 23 here, right? Now on my other side of the equation, I have 6 times negative 5. That's negative 30. Negative 30 plus 7. Well, again, that's the absolute value of negative 23. Both those are the same. Great. Our first solution worked. I could repeat this as well with my second one if I want. I'll go ahead and try that out. We'll see how it goes. It's a fraction though, so a little difficult. We'll see. Negative 2 over 5 would be negative 0.4. I'm actually going to write it as a decimal here just because it's easier to multiply. 4 times negative 0.4 should be negative 1.6. Negative 1.6 minus 3 would be what? Negative 4.6. I hope I'm doing my mental math right. Over here, we get 6 times negative 0.4. 6 times negative 0.4 is going to be negative 2.4. We have negative 2.4 plus 7. Same thing as 7 minus 2.4. And that's going to get us positive 4.6. Now those numbers look pretty similar, but there is a difference. This one's negative, that one's positive. Is that okay? Does that mean our answers still actually got me the same thing? It does. Because let's remember what's around those numbers. Absolute value bars. Meaning no matter what, if the number in there is positive or negative, it's positive. So even though this looks like negative 4.6, it's positive 4.6. Same thing here. It looks positive and, well, it is positive. So they're still the same number. This is what we do though. I know it looks like a lot more work, but in practice, it's not actually too bad, I don't think you'll find. Again, our main goal is just take the original equation, rewrite it twice, with one of them where we flip the signs on the right-hand side. We flip every sign. And then we just solve each of those for our answer. And we're done. If you have any questions or have any specific examples you want to see worked out, feel free to drop them in the comments below. Otherwise, see you guys later. Thanks for watching.